11 greetings. Today we are going to solve question number 1 of October-November 2024, A levels paper math 3 paper 3. So that's pure maths paper. The first question is that expand 9 minus 3x to the raised power half, or we can say that it's under root of 9 minus 3x. We can also write this, but that would not help us to get the expansion done. Ascending powers up to x, so including the term x squares, that means simplifying with the coefficients. This will be solved by the help of binomial expansion or binomial theorem, but till x square term it means factorial of 3. So if you don't remember the formula, I'll write the formula first. So obviously you should remember it, and you don't need to remember it, it is already given in the data booklet. So just to recall it, that how it needs to be in the form of this, because at the moment it is not the bracket is not in the form that can be expanded at the moment. So that's the formula. Now instead of the term 1 plus x, we have 9 minus 3x. So the thing is that we need to get this 9 out, and then we can simply solve it. So first of all, let me just take a common, that is 9 to the raised power half. So but this would create a trouble, because x, it was only x 3x over there. So if you multiply this, we don't need to multiply 9 9 raised to power half with the 3x. So that was minus. So this needs to be written down. I'm just writing 9 because we know that this whole bracket has to the power this. Now we know that this 9 to this would simply be 3, and now we can observe that the inner bracket would also solve, leading to this 3 times 1 is 3, 3 times 3 is 9. So this is in a term that can be simplified and expanded using your binomial theorem. So let's solve it. Three is the first term as it is. So in the brackets, that needs to be solved because the theorem would apply to that bracket. So the first term is 1, just write 1 as it is. Then you have n is 1 over half. 1 over 2, or we can say that half, times x. No, over here the x is this whole term. So I would simply write x as bracket minus 1 over 3x, or you can just simply write minus x over 3. The second term is just the power, that is this, and then half minus 1, and then x squared. Over here x was termed as this square over factorial of 2, and this would go on like unlimited factorial till the n terms is given. We don't have it, so we'll just write as it is. Now this can be further simplified by multiplying this. So instead of plus, we would just get minus, because it's multiplying. So we'll get 1 times 1 is 1, and then you have 6. This stays as it is. In the factorial one, we just have this. So the inner bracket would be solved by just multiply with this 2, and this would also be multiplied with 2, and this would just be squared as positive 1 times 1 negative so that would give you positive 1 over 9, and then x square also plus, so let's solve this. Almost done. 1 over 6x plus, and this would give you a multiplication with minus half, and this would be just, you can write x square over 9 plus, and that's just 2. So you would have minus x over 6, and this would give you just minus because you would have 1 over 4 and times x square over 9 over 2. So 1 minus x over 6, and this would be 36, and over 2, this 2 would also come and multiply with this. I've done some, let me just resize it to make some space. So the final answer, not the final, because this 3 has to be multiplied with that. So this would be just x square over 36 times 2 is 72. So if you multiply this 3 with that, so you'll get 3 minus x over 2 minus x square, and over 3 divides into 24 times. So this would be our term in terms of x square that was required by the examiner. So that is our answer. I hope you understand this.